I'm doing DML operations, but I tend to not do it because I'm busy. I've got a lot of things to do, so I skip over it. But with encapsulation, I can do a much better job. And finally, and perhaps most importantly, greatly increase my productivity. I don't want to spend a lot of time writing SQL. We think of it as being this critical aspect of being a PL/SQL developer, but it's really a very low-level operation in our code. I want to spend as much time writing business requirements, implementing business requirements as I can. And doing this, creating a data access layer, can greatly increase my productivity. Now, I'm going to show you examples of these last two benefits in the context of how I write my applications in a particular application called Quest Code Tester for Oracle. But first, let's talk about that first benefit. Change or improve my implementation with minimal impact on application code. Let's take a look at a feature called the function result cache. This feature was added in Oracle 11g, which hopefully you're going to be on very soon. And let's talk about what it does. And first of all, let's talk about the way we write our applications. Here's a procedure called do stuff with employees. Pass in the employee ID, get a row of data from the table, and then do stuff with it. And here you see an example of an unencapsulated raw query. I needed to get the row of data from the table. I just write the select statement. I've got my record based with %row type on my table. Why not? Why wouldn't I do this? In fact, I do it in dozens, maybe 100 places in my application. It's one of the most common queries I would write. So, if I add 5 columns to this table, will I have to change this select statement? Will I have to change this part of the program? And the answer is no. I've actually written this code so that it's quite resilient to change. If I add a bunch of columns, this program will be marked invalid. Upon recompilation, it'll automatically pick up the new columns in the record. It'll automatically get all the columns from the table with select star. This is a nice piece of code. And it shows some of the nice features of PL/SQL: automatic recompilation, dependency management, anchoring with %row type. So the problem with this exposed query is not that it might change over time. The problem is that it's hard to optimize it, and it's hard to take advantage of new features, which the function result cache is one of. Now, before I introduce the function result cache, let's just take a look at how I write my applications. I don't do this. I don't write select statements all over the place. What I would do is take advantage of my generated API, which I'll come back to in a moment. So I declare my record based on my employees types package, record type, and more importantly, I populate my record by calling my query package one-row function, pass it the primary key, return the function. So I don't write SQL statements. I call functions that do the work for me. I'll give you more of a sense of this API when we move on beyond this one topic, but that's an example of how I would write my code versus you. So you've got 20, 50, 100 of these queries. I've got 100 calls to my function. Then we upgrade to Oracle 11g. Now, here's an approach. Let's talk about several different ways that I can access this data in this table. One approach is what I just showed you, getting the row, calling the query every single time. So my one-row function, this is the way it was written back in prior to Oracle 11. It's the same select statement that you saw here. I've simply moved it into my package. So this is what you would find in my query package. So look up the row every single time. And at least it's hidden away. I don't repeat it over and over again. Another approach I can take, just to give you an example of an alternative, though I'm not going to get into detail on it now, is PGA caching, Program Global Area Caching. What I'm going to do is copy the data from my table into a cache of data, which is a collection inside my package, and then I'm going to retrieve the data from my collection. This is a much faster mechanism than querying over and over again, but your table has to be completely static. So we'll just use that as a counterpoint to querying every time. Finally, what I'm going to do is go back to my original package and add the function result cache. So I go to my function that existed already. Here it is, my select statement, hidden inside my function. And all I'm going to do is add a keyword, result cache. And in my package body, I'll add the result cache keyword as well. And in 11.1, I have to tell it that it relies on the employees table. In 11.2, which we're most likely going to be using, as I am here, you don't even have to specify the relies on clause. So I've got 3 different approaches to querying my data. One is the query every time, which is what I'm doing right here. I've hidden my query away, and I call it here. The second is using this fancy PGA cache. And the third is a very simple change to my existing code base, which is add the result cache keyword. So what I'm going to do is create these three packages, and I'm going to compare the performance of them. Did that all work? It all worked. Let's do the comparison. First, I have to create my comparison program. So what I'm going to basically do is take advantage of my timer package to start my timer, run my code, and then show the elapsed time. In fact, I'll do a slightly different version of this to simplify matters. So the timer package is in my demo zip, and I can say start my timer, run my code n number of times, and then show how much time has elapsed. And I'll do this for my 11G result cache, my PGA cache, and executing my query every time. Compile this code. Whoops. Let's see. Let's get rid of that. Compile my code. Run my script. And I'm going to do it for 100,000 times. So 300,000 accesses of the single row of data over and over and over again. Should take about 4 seconds. And here's what I see. Executing the query every time. Inside my function, but still executing every time. 4.19 seconds. The cache table in the PGA memory, 0.08, lightning fast. Much, much faster than 4 seconds. But it's got a lot of downsides to it I'm not going to get into in this section. Basically, you have to have a static data set, and it can consume a lot of memory. The 11G result cache, the new feature in Oracle 11G, does the same query processing in 0.17 seconds. 0.17 seconds compared to 4.19, and it doesn't have any of the downsides of my PGA memory cache. It's an incredible feature added in Oracle 11 that can have an amazing boost on performance of your application. So that's the basic idea behind the result cache. I have this one keyword, and what happens is that instead of executing the same query over and over again, it remembers that somebody already tried to get the data or got the data for employee ID 138. So rather than call the function again, it simply returns the data that it cached inside the SGA. It's an amazing feature. There'll be separate lessons on it inside the video series, inside the PLSQL channel, so check out the function result cache. But the point I want to make here is that because I put my code, my select statement from the employees table inside my function, I didn't call it over and over again. Let's in fact go back to my original file so we can reinforce that point. Here's an example of calling the query over and over again in my application. Here's my call to my function. Because I was careful enough to call the function always and never write the select statement, then in nothing more than a minute or two, I can add the result cache keyword to my existing package, recompile my package, and see an enormous boost in performance. An enormous boost in performance. From 4 seconds to 0.17 seconds for a minute's worth of work. And I can go to my manager and say, hey, look at this. After just a couple of minutes, I was able to upgrade this application. We see fantastic performance. Isn't that great? And my manager will say, wow, Stephen, you're amazing. Now, everybody else who took this approach, who wrote the select statement over and over again in their applications, they'll learn about the function result cache. And they'll say, wow, I'd really like to use that here. And they'll go to their manager and say, manager, I've identified 55 programs in production that we will need to change in order to take advantage of this incredible new feature. And chances are your manager will say, that's interesting, but we can't afford to do that. It would take too long and it would be too expensive. So the point here is, after this very long story, is that by hiding my select statement inside my function, I was able to make a change to the implementation of my function, leveraging this new feature, the function result cache, without any impact on my application code at all. Nothing changed except for an incredible burst in performance, improvement in performance. But if I expose my select statements all over my application, chances are I will never be able to take advantage of new features like the function result cache, at least as effectively and thoroughly as I could. Instead, my application will look older and older and older as the years go by. I'll be on Oracle 13, and my code will still look like I'm running Oracle 9 or 10, because we were never able to find the time to go through the entire code base and make these changes and make these improvements. So if you hide your SQL statements behind your data access layer, you will have an opportunity to very easily upgrade that code as Oracle comes out with new features, as Oracle gives you new and better ways to do things, as you figure out new and better ways to do things. And that's the primary benefit. I think the biggest, the most powerful way that I can try to convince you to hide those SQL statements behind your data access layer. Moving on, let's take a look at how I do data encapsulation. So one of the products I've been involved with for a number of years is Quest Code Tester. And Quest Code Tester is a tool that helps you automate the testing of your PL/SQL programs. You can basically define your tests, you can run tests, and automatically figures out the results for you. Really fine stuff. Now, Code Tester has a backend Oracle repository, about 35, 40 tables. And we have a very small development team. I'm the main backend developer. So I've decided that what I'm going to do is follow a data encapsulation approach. And my approach is that for every table in my schema, I have 4 packages. 3 packages are generated. One is my change package. It has all the DML operations, update, insert, delete. Query package, get me one row, get me all rows for a foreign key, get me all the rows and pass it back as a cursor variable. So all my retrieval mechanisms. And my types package that basically predefines a set of subtypes for my row types and my percent types on all of my columns. So this is my common set of 3 packages per table: change, query, types. And as I'm about to show you, these are generated. I don't even write them myself. Now, you can't possibly generate everything. You always have to write some custom logic. The main thing is following the principle, just write it once. So for most of my tables, I have a 4th package, the XP package, the extra stuff package. And if I need to write an SQL statement or need to execute an SQL statement that's not automatically generated for me, some complicated, unusual update statement, then I'll write the update statement, but I'll put it into my XP program, XP package, and then basically call it from the package. So the rule is always the same. Never write an SQL statement directly in my code. Always call a procedure or function that does the work for me. If I can generate it, great. If I can't, well, then don't. So let's take a look at my backend. Here's my code tester backend schema. As you can see, I've got a lot of these QU tables. The QU tables are part of the backend repository. And if I look at my list of packages, I've got a lot of packages. QU, QU, over and over and over again. Now, you can often be intimidated by a large volume of code, but when it follows a clear pattern, it's not as intimidating. For example, test case, CP, QP, TP, XP. So 4 packages. At a glance, I know exactly what each of these packages are for. Let's take a look at the query package. Get me one row returning a cursor variable. Get me one row returning a record. Does a row exist? Get me all the rows. Get all rows for a foreign key. All of this is generated code that I don't have to write myself. Change package. We've got inserts. We've got updates somewhere in here. Here's my insert statement, update statement, update by primary key, delete by primary key, delete by foreign key, delete by unique index. The point is that this tool, and I'll show you the tool that generates it for you, basically looks inside the data dictionary, finds all the information about primary keys and unique indexes, and generates patterns of code that likely match the kind of thing I'm going to need to do. So instead of writing things over and over again, I can just call programs in this package. So there were 2 more benefits I wanted to talk about. One is improved error handling. The second one is improved productivity. First of all, error handling. Let's go inside the body of my change package for test case. Come on. There we go. So here's my change package body for test case, 4,000 lines long. Great. Lots of code for me to use. Predefines a bunch of exceptions. Then we've got an insert statement, an insert procedure. Here's the base insert. I have an argument for every column. It does some tracing, and then it does the insert. And that's it. This procedure does nothing but an insert. So you might say, well, why bother writing a procedure for that, for the error management code? Let's take a look. Here's my error handler, or my exception section. It starts on line 244, and it goes, and it goes, and it goes, and it goes to 427, 200 lines of error management code. Much more detailed than anything I'm ever going to write. Keeping track of the errors that show up, whether I'm using a for all or a single insert. It's really pretty amazing stuff. And this is the sort of thing that you would never find the time to write because you're too busy, you're too pressured for time. So by using an API like this, you can write it once and put in a lot more error handling or generate it with a lot more error handling. But the bottom line is your ability to understand what went wrong in your programs, to manage your application, to support your users when errors occur, goes up dramatically. And again, you'll never find the time to write this yourself. Finally, productivity. So suppose I'm writing a new program in my application to process inputs for a given test case. So inside CodeTester, I have given various test cases. And for each test case, I have multiple inputs for the different parameters in my application, essentially. So I want to get all the inputs for a test case. Now, what I would normally do is write I want to do a bulk collect to get a high performance retrieval. I need to define a collection type. I need to declare the variable based on the collection. I need to write the bulk collect statement, but not with my API. Instead, I'm going to say, well, I need a list of inputs. So that's the QU inputs table underscore TP. Get me a type. Dot. It pulls up my list of types. And there are a lot of predefined types. But the point is that the naming standards are very clear. So once you get the idea of the naming conventions, it's really easy to sort out. So for example, I want to get, whoops, what happened? My resizing seems to have made it difficult for me to type. Is that true? What happened? Sorry. Okay, I think I found a glitch in Toad. How do I get out of it? There we go. Okay, so sorry about that. Press dot, it shows up my list, and I know that I've got a collection type called my table name underscore TC, table collection. So I don't have to do my own type statement. It's right there. And then I need to fill it up with something. So I write the name of my table underscore QP query package dot. Again, lots of programs, but I know that all of my foreign keys are prefixed by AR, all rows for the foreign key. Just find the right foreign key, pass in my test case GUID, and I'm done. Whoops, I need an assignment statement. So in just a few minutes, barring that odd little departure, not being able to select from my list or type, I was able to declare my collection based on a predefined type. I was able to call a function that does the bulk collect to retrieve all my rows into my collection, and I didn't have to write all that stuff myself. I just had to pull it off the list and then pop it into my code. So the benefits, the productivity benefits of a data access layer are extremely high. Well, hopefully I've convinced you. This is great stuff. This can make an enormous difference in your productivity and your code quality, but it's not an easy thing to do. If you're going to build a data access layer, it has to be very consistent. Otherwise, people get lost in the different ways that you name your variables and which things you should be using. It has to be well designed and efficient, or nobody's going to use it. The best thing to do is generate as much of the code as possible. Again, the principle is you as a developer should not be writing SQL statements over and over again. Now, certainly there are many tools that generate lots of SQL for you, like Application Express or Hibernate for Java developers. That's fine. As long as something is doing the code generation and you're not writing it yourself, that's good. You don't have to put all your SQL in your own custom data access layer. You just have to avoid writing it. But when it comes to the stuff that you need to write, my suggestion is generate that stuff as much as possible. And then for the things you can't generate, place all that custom SQL in its own container, usually a package like my XP packages. And then at least you know to go back to that one package if you need to do something out of the ordinary or write something new and add it to the repository. Now, in terms of ways to generate these kinds of packages, what I use is a utility called the Quest CodeGen utility, available at PL/SQL Obsession. And it's a freeware product that you can download and execute and use. Here's an example. Oops. So here's my CodeGen utility. It's basically built around a script repository. I've predefined a whole lot of scripts, including my table API definitions that has a change package definition, query package types. And all I have to do is click on the Run button, choose the database objects that I want to generate for. I can set different argument values for the way that I want my code to generate. And then about 10 seconds later, out comes code. So for the employees table, I've got a change package specification, insert an employee, update employee, delete employees, delete by foreign keys, and so on. I've got my query package to retrieve data. All this is generated for me. I save it out to file, I add it to my install script, and suddenly I have this enormous toolbox of code to use as a data access layer. The CodeGen utility is not the only way to do this. Lots of people build their own data access layer generators. Oracle has their own tools as well. Pick the approach that works for you, but stop writing all that SQL yourself over and over and over again. Conclusions. SQL statements are among the most critical parts of your application. They involve performance impact, they involve constant change, evolution of the application, and lots of potential errors from your users. Stop taking it for granted. What you need to do is set a clearly defined body of rules and guidelines on how, when, and where to write SQL. You should have a set of rules that dictate how people write the SQL statements in your application. And then, apply the most fundamental principle for high-quality coding. Don't repeat anything. Don't repeat SQL statements. More important than anything else. Hide these statements behind an encapsulation layer, and then call those programs to get the job done. Better productivity, better code quality, and potential for greatly improved performance, especially when you can leverage a feature like the 11G function result cache easily and quickly in your application. So next steps, download the demo zip if you haven't already done so. Try out the different approaches I've shown you here for data encapsulation. Check out Code Tester and the approach I've taken there, and explore the function result cache, which is not the focus per se of this lesson, but is a critical feature of the 11G database. Watch the other lessons in this series. If you haven't already, check out Introduction and Concepts. Learn how to avoid hard coding of magic values, declarations, rules, and formulas. I hope this lesson was useful to you. Data encapsulation, building an SQL layer, is certainly among the more complex and challenging things you can do in terms of changing the architecture of your application. But it has enormously positive benefits. I really hope you'll give it a try. Sit down with your application team and discuss how you might go about changing the way you write the SQL in your applications. So, best of luck to you, and happy PL/SQL